Hi, everyone. Welcome to the Future Construct podcast. I am your host, Amy Peck. Today, we have an amazing guest, Burcin Kaplanoglu, who is the Vice President of Innovation at Oracle Industry Lab. Welcome, Burcin.
Welcome, and thanks for inviting me.
I am so excited to get started. I think maybe you have one of the coolest jobs on the planet. So maybe we'll start there, and just dive in on, what is your day-to-day at, how do you think about innovation at the lab?
Well, I think I want to explain to the audience a little bit what the lab is about. So it is built as a simulated environment where we can test technologies. So every day is different. Every day is different to the sense that one day it could be us trialing a robotic technology with some customers and partners. Another day would be having some visitors come and experience some of the prototypes we built. Another day could be just having workshops and trying to figure out what problems we need to solve. So it is different every day. I think that, and it's very dynamic, and I think that makes it pretty exciting.
That's amazing. And then, in terms of how you experiment, is it driven a lot by customers, or do you have sort of a plan, like just we're going to work on all of these technologies this year and it just organically leads from project to project?
So it starts with customers first, and we also have a lot of engagement ecosystem with partners, also with other institutions. But what we do at the lab is actually reverse of most innovation labs are. Because we actually look at, really, we bring the problem first and we don't focus on the technology. That's the starting point. So we figure out what exactly the problem we need to solve. Then we map out the business process, the skills that's required, and then the technology. This might sound different for working at a technology company, but we actually start absolutely the problem first, then go in the process, then goes on the skills, then the tech, then figure out where our tech fits in, where partner tech fits in, and then iterate. We just try it, right? So I think that's one of the biggest things is there are innovation labs existing in multiple industries, and I have been to many of them before I joined Oracle. I was an Oracle customer. I work at a publicly traded global company, and when you went to those spaces, some of them really felt like museums or exhibits, and it was big shiny objects, but you couldn't really relate to it. So what we have changed, and that's the key here, is we create an environment where it doesn't feel like a museum or an exhibit. It actually really works out in that manner.
And to me, that's smart too. I think there, especially with a lot of hype around certain technologies, it's easy to fall into the trap of technology first, as opposed to, what are your goals? So you mentioned that you were at, a large publicly traded company before. Can you share a little bit about your journey? Because I always find it fascinating, how people land where they land, especially, where you are at the bleeding edge of technology. So how did this all start for you?
So let's go back in time. So I'm a civil engineer in training. So I got an undergrad degree in civil engineering. Then I got really interested in project management at that time. So I got a master's in project management. And then while I was doing that, I was teaching like a TA, and I really enjoyed teaching. So I realized that, okay, I want to do that. But I also didn't want to give up the chance to work in the industry. So I moved to US in almost 21 years ago. And when I moved to receive my PhD. So I was fortunate enough that I actually was able to work pretty much most of my PhD time. So I actually worked full time in that publicly traded company. And that almost worked 16, 17 years in one company. So that's also another unique thing, I think, for my generation to work in a place that long. And throughout that career, I had many different jobs. I had to write my job description 3 times because it didn't fit into anything. And I was fortunate enough the company allowed me to do that. And, last thing I did was working on telecommunication and, had innovation projects that we were trying and establishing. Then Oracle actually came and asked if I would join them to lead innovation, and the rest is history. So, but I did also teach. So again, my career, if you were to look, they are all done at the same time. So working in the industry for almost 16, 17 years. I've been teaching at Northwestern, I think now 12, 13 years. I lost count of time. And then I've been interested in the tech and actually application of the tech to solve problems in construction for a few decades or so. So I've been doing all this parallel that led me to my current role.
And so, I mean, what an amazing career. And I don't know how you were able to, have a job and manage to do your PhD at the same time. I think there must be some trick that you've learned on stretching time, but we'll talk about that.
Yes.
So in terms of solving problems in the construction industry, because that's something obviously that we talk about here quite a bit, and there are so many incredible forward-looking companies who are leveraging technology today in really interesting ways and blazing a trail. But then on the other hand, there are still these kind of archaic processes and systems and very analog. How do you see, technology or even just information getting out there and starting to permeate to the point where people are really, it's just more broadly adopted, I think, in the industry.
Yeah. So let's talk about where we are. What we have been living through the last 2 years, the challenges that we have absolutely accelerated the transformation, no doubt about it. I think we all know that. And I can give you specific examples, right? If you run a software product on your machine that was in your office or in your trailer, well, you had to be able to access that remotely, right? So that's what the cloud really become a necessity. You couldn't really run, on premise anymore because you actually have to access. But what you're describing is our biggest challenge is our competition is pen and paper and also Excel, right? So if and many times I think people look at this and say, well, I'm using my phone, smartphone, I'm using my laptop, so I'm digitized. That's the beginning, right? So those are just tools. The reality is there's a lot has to actually happen to improve the process. So what I really want to highlight is this. I think a lot happened in the last 10 years about us using digital tools, but we are still in the early stages of changing how we do things. The process is still the same. So if you look at our industry and you look and say, how do you put up a drywall? How do you, build roads? How do you, infrastructure, warehouses? Like, look at the techniques that we use. It's the same technique for 100 years. It's not that much different. We might have, greater tools, cameras, visibility allows us to look at these things. That's great, but we're not doing it differently. So I think the real value is going to come in is as we're digitizing more, is how we actually changed how we do this. The process is the really key here.
So you mentioned infrastructure. I think on a government level, and in many municipalities, there was a disaster a short while ago in Miami with buildings collapsing. So it feels like there's kind of a two paths here that need to be addressed relative to infrastructure. One is, how do we retrofit, which I think in many ways is kind of a bigger challenge, more urgent challenge. But then the other is, how do we build then these processes so we don't get here again in the future? And I imagine you're looking at both sides of that coin. What are some of the things that we should be looking at in terms of shoring up the issues we have today, but really being smart about how we build things in the future?
Well, let's start with what we have today. I think there are organizations out there which is been surveying these infrastructure, pieces and parts for a while. So I think we have a pretty clear idea of where they stand, and it's not great, right? So we all know that. So if we're just looking at North America, looking at US, we need to do a lot of work. So that's, I think, where it comes to process optimization or automation, right? A great example of use of drones for bridge inspections, right? it is cheaper, it is safer, it's faster. So if you look at all those, it makes no sense now to actually have a lift or a bucket or something to be attached to the bridge and put people's lives and tie yourself like this. It makes no sense, right? So if you follow this and you say, if you can do it cheaper, faster, safer, and quicker, right? So all those reasons why you should do something else. So I think transformation is happening in terms of data collection. So there's a lot happening right now. And then it's all going to be about prioritization, right? So I think we're going to prioritize and do that. In terms of how we do it differently, so a lot of infrastructure we have was built in 50s, right? So if you look at that infrastructure, roads and even like power grids and other things, I am a big believer on offsite manufacturing, offsite construction, manufacturing, prefab, and really bringing the quality into it with having the end in mind. So really anticipating what will be and then mass produce these things and actually put them in one place. But we have, we have challenges beyond technology or the process. Let me give you one example. One of my previous roles, working with a group to figure out, can you standardize and have a new technology to build cell towers? It was done before, and it was done in a different country, and we were trying to see if we can replicate that in the US. But here's what, in US, everywhere has different zoning requirements. There are some standards, but it's different. But not only that, how people interpret those zoning requirements is different too. So it's 80% science, 20% interpretation. If any of you who's listening to me have done a home renovation or something that required permit, will know that when the inspector shows up, they interpret a lot of things. And they might say, well, that's not acceptable. But if you read the code, your interpretation might be different than their interpretation. And then when you ask them why they see it that way, they'll say to you, well, that's how it's done. Like that's my job. And I'm telling you, this is what it should be, right? And you have to go correct that. So if you look at all this, I think we also have some challenges, not just the process, not the tech, but how the industry, all the rules and regulations are set. And if you really want to scale these things, like housing, like affordable housing, or infrastructure, like cell towers, or figure out a way to have one consistent way of building these roads, right? It's going to be challenging because our rules and regulations are different depending on which state you are, or even counties are different. They have other requirements, right? So we are not making it easy for ourselves. Let's put it that way.
Yeah, no, and you bring up a really important point is being able to do scalable, repeatable processes. And as much as I'm a big believer in humans being part of the technology process for the type of critical thinking that we can bring to it, the other piece is that kind of lack of consistency. And have you seen opportunities? I mean, we certainly have things like computer vision, we have machine learning, and moving into kind of deeper, more in-depth algorithms for AI. Do you see a point where we can start to actually have a baseline of interpretation of what a permit requirement is that is done automatically, and then those results delivered to an inspector or someone from the city or county or whoever happens to be in charge to really help sort of streamline that process? And what are some of the challenges of adopting that kind of technology, and can we trust it?
And I think I have seen studies and I've seen research in the last decade where people are trying to automate some of that. Like, can you automate the building permit process? Can you automate some of these things? And again, going back to my previous statement, it's 80-20. So I think you can automate a lot of things, but then when the human interpretation comes in, you need to have that. But there are, and I'm going to tie to something we discussed a few minutes ago, there are huge advantages to technologies you just highlighted. So let's say you have drones fly, capture imagery, we can attach LiDARs, other things, heat sensors, whatever it is, right? You collect all this data. You can definitely have systems to actually analyze this and prioritize which bridge has to be, top priority. Like you definitely can do that. So I think there are a lot of benefits to it when you want to prioritize things, but human still has to be there. I think eventually we are still the final decision makers. We still have to do that. There are studies that are showing up when you have artificial intelligence, which is mostly machine learning today. When you have machine learning and human working together, the benefits are higher than individual by itself. A good example, not from construction, research came out almost 30 days ago about in healthcare. They looked at how it can help detect certain types of cancers, but then the doctors, medical professionals doing it, and the research showed up, the two working together was much more productive than actually by itself. AI sometimes recognize things that humans couldn't, which end up helping. Vice versa, humans were able to identify things because they have decades of experience and certain things they can recognize, but the training of that model didn't actually catch that because they didn't have that experience. So I think working together is a solution. Tying it to infrastructure is really important, like you said. How can we detect this? How can we prioritize this and pull this together?
I love that you said that, because I'm a big believer. One of the questions that we get a lot is robots are going to take our jobs, technology's here to take us away, and I think it sounds like, and I don't want to speak for you, but I'm actually a big believer in, again, that kind of symbiosis. Like, we use technology to actually elevate our level of understanding and information around a particular topic. And then, but we are that last mile, right? And, but then moving towards sort of the future of optimization, can we talk a little bit about, simulating some of these outcomes and some of the work that I think you're doing in the lab?
Yeah.
Where, we can build entire digital twins before, even, one brick is laid on a construction site, and model out, the construction process end to end, and even, build in some of that, essentially sort of what could become the as-built, sort of a living, breathing as-built that gets, updated through LiDAR and sensors through the process. How advanced is that today, and how much is that streamlining the construction process?
So I think it is rapidly advancing. Let's start with that. Like, I will give from, what we are working on. So we have a smart construction platform, and part of that is called Construction Intelligent Cloud. Now, let me give you one example of that. As we all know, we've been struggling with supply chain issues, right? It looks at the supply chain historical data, and it says to the system, well, there is 90% probability your project is going to delay for 5 days, and here's why. You have the ability to accept that or decline that. And based on your acceptance, or if you decline, it actually adjusts the model. So it's called reinforced learning. So basically, you can actually do that. Many of the machine learning solutions that are out there today doesn't do those two steps, which is, it doesn't tell you why exactly it made that prediction. It also doesn't give you the chance to go and adjust the model so it learns from human. What you need to do most of the time is, and many people in the industry are doing today, is you hire data scientists, you have access to software, give them your data sets, put some hypothesis, have them build these models based on that. But tomorrow, if you want to make a change, you have to ask that person to go make adjustments to it. So I'm talking about having software product which makes predictions, tells you why it made those predictions, and you were able to go back and make changes to it. This is the next evolution of artificial intelligence, machine learning coming to our industry. Because if we have that, and look, we're skeptical people, I have to say this, okay? We're engineering and construction. We build things are tangible. We need to touch them. We need to feel them. Many of us got into this industry because it's tangible. Like, I can walk, I'm in Chicago, I can walk downtown Chicago and point buildings I worked on, and I will be able to do this. I will be able to show it to my children, right? We like tangible things. So when a machine tells me, oh yeah, this is what's going to happen, we're skeptical. But if it does explain to me why that answer, why it come to that conclusion, and I have the authority to adjust or make changes to it without talking to a data scientist, without actually really understanding, all the technical things, that actually gives me more comfort. And I think this is the next evolution of software coming. And those are the things that are, what I'm describing is available today, by the way. This is not a prototype. This is not, it's going to come in 5 years. This is stuff that's actually available today.
So I want to drill down into this, but we're going to take a short break and hear from our sponsor, and we'll be back in just a moment. All right, we are back with Burcin Kaplanoglu, the Vice President of Innovation at Oracle Industry Lab. It's been an amazing conversation. I'd love to just kind of continue on this thread and see, what are some of the other trends that you're seeing in the industry where you're seeing incredible optimization opportunities?
So let's start with the good, bad, and ugly, right? So the good one is there has been a big push happening in prefabrication, manufacturing, automation. The bad side is last couple of years that actually has taken a toll on the industry because certain companies which were set up to do this, unfortunately, are no longer in operation. The environment changed, business dynamics changed, and the demand has changed. So that affected big time. So I see this as a setback. I don't think it's going anywhere. I think it is going to pick up. We are going to have much more need. And if you look at from infrastructure, we talked earlier, from buildings, homes, like there is still huge demand. We haven't really built that much in the last 5 years as we should be. And home prices are going up, right? So we are seeing a lot of changes happening now. I think this is one of the key things that is really going to drive our industry. And that's totally believe is the future. So in the short term, I know there's been some setbacks, but in the mid to long term, I think it's going to come back, and it's going to come back stronger than it was before.
Yeah, they definitely agree with you there. And, in terms of even, robotics automation on site, leveraging, LiDAR scans to be able to kind of record progress in buildings. Are you seeing some advancements in those areas? Because I'm still, I probably bring this up on every podcast. It's probably too much. Everyone's sick of it. But I find it amazing that we don't build the as-built as we're building the building. Because we have the technology. So what are some of the end-to-end ways that that in and of itself would save so much time and money, in the building maintenance life cycle?
Absolutely. So let me give you a specific example. So the image the audience is seeing behind me is the Oracle Industry Lab in Chicago. We did exactly what you said. So it was in the contract. The building as built is built, and we fully received it as a digital at the end of the project. It was built as it was being built, and we basically exercised that. So now the operations actually have a full 3D model, and all the O&M, all the information that's required is in there. Now, one thing we have done, and this is totally being practical, and your audience probably can relate to this, is you don't really need everything in a model to actually use operations. Like the chances of us replacing ceiling tiles is going to take years. But so we actually prioritized it. So when we talk to when we give the requirements and said, well, here's everything we are aware of operational that is going to require all the specs, all the background, all the data we need. We don't need ceiling tiles. We don't need doorknobs. We don't need the underlying. Look, they're showing in the model. So let's clarify. The model shows up, right? But the metadata is not in the model. So we prioritized because look, we had the opportunity to have everything in it, but we're also realists. Like this industry, it doesn't really bring the value to have all those components today. And if I need it, I will go find in my project management system what they were because I had them approved during the design and also construction. I can find them, but in the model itself, we prioritize the things that are operational, like from HVAC, mechanical systems, from like even audiovisual. So this building has tons of audiovisual, some other technologies that are embedded. We have sensors. By the way, we did build a data lake for this building. It is collecting tons of data, occupancy, all the stuff. They're all in the light fixtures. It's all LEDs. It has solar panels, Tesla Powerwall, all those things that you can imagine. We also built an apartment unit in this building behind me. And the idea was, if we are going to innovate, we need to see how, at the end of the day, our customer live their lives. And how we actually, in that apartment unit, we have full kitchen, appliances, washer, dryer, Tesla Powerwall, inverters, and it's all built for trial and testing. So when it comes to energy, as an example, some use cases when I share with the audience. So we were able to go, let's say you live in your house and there are products we have that will make recommendations to homeowners, and utility companies actually use that. So when you receive an email and says, hey, you use this much energy versus your neighbor, and this, if you do this, this will be the impact. Most likely it's us running the analytics and sending that information to you with the logo of the utility on the top. That's us doing it. So take that logic. What if we were able to go and then you decided to make a change to when you charge something? What if then we could actually go into the network and be able to adjust that remotely? You just said on your phone, I agree to do this. So you don't actually physically get out of the couch, go there and adjust, or pick up your phone and adjust it, right? Because those are all different applications. So those are the things we're trying. So this is why the lab is built, right? It's built as a physical test bed for us to see how can you build physical infrastructure and pull it together and do these trials.
That makes me so happy, because it really is truly even a step beyond, looking at sort of problem first and then bringing technology in behind it. It really is user and human and lifestyle.
Human-centric.
Yeah.
Human-centric. I mean, that's why human-centric design is important. But what we're doing is we're putting human at the front end. We're also putting the problem at the front end. And as you said earlier, many cases there's technology being developed, and then those technologies look for a place in industries. They're looking for a place to actually solve a problem, and which is still relevant, by the way. It's going to continue happening that way. There's some technologies which is going to come, it's going to impact multiple industries, which is relevant. But this time what we're doing is we're looking at the human first, human-centric, and then also the problem, and then bring the tech and the process and the skills later on.
I love that. And as much as I do not want this conversation to end, we are running short of time. So I do want to save time for my final question, which I ask everyone, which is that if you could project yourself 20, 25 years in the future, which you do on a daily basis, but from a personal standpoint, if you could have any product or service that would just make you happy or in some way make your life better, what would it be and what would it do?
So I'm looking for something that's going to help me with the house chores, especially like dishwashing, right? So putting them in the dishwasher or taking them out or helping with the house chores. And clearly I didn't use the word robot here because I think there's a lot of thought, thinking around, is this going to take over my life? Is this going to do all those things that by the way, we have been watching on these in movies for the last 30, 40 years. So we are all scared of things that's gonna, take over. I'm also a firm believer of, as long as we're aware of it, I think we will find a way to manage it. In the industry itself, also in construction, I do not see robots taking over our jobs in the next at least couple decades or 3-4 decades. I mean, I think it's going to be helpful to us, and the things that are repetitive and the things that are not safe, we can definitely outsource them, right? So what's the point of doing this repetitive task over and over again? Well, we can use human skills, human training in much better ways. And there's a giant labor shortage. So we have to look in this way and say, we have to fill in those gaps to actually deliver the things that the world needs. And I did mention, look, we in the industry, this audience, we are fortunate to coming from an industry that things are tangible. And we build this world, right? but we also can not be delusional and think that one day we're just going to build everything from scratch. So what we have today is okay, is not great. It is upon us to figure out how to improve that and how to leave this world a better place for our children than, you know, what we have achieved. So I think as the construction professionals, as the engineers who are listening to this, designers, the whole audience, the real estate owners, property owners, everyone else, we have a responsibility to actually make sure that happens.
I could not have said it better. This is the mic drop moment. Thank you so much for being here and sharing your experience and expertise with us. It's been an absolute pleasure.
Thank you.